Okay, starting off where we ended up on the previous video, we're looking at a box plot of the residuals. I know you woke up this morning thinking, gosh, my life would be so complete if I just knew how to do a box plot of the residuals. So there you go, we got one. Alright gang, at the end of the day, why do we do residuals? Well, you know, they tell us some cool stuff, and they talk about the error in our model. If you think about really a residual, what's it doing? It's examining the difference between what we observed, the data that we collected, the measurement that we got in our that we have in our data set, and what we actually predict. So it's a difference between what we observe and what we predict. So it's kind of the error in our model. But there's a little bit more going on, and what's really going on here is residuals allow us to address an important question. And wow, it's so quiet. Is a linear model appropriate? Well, that was crazy. For describing the relationship between X and Y. So gang, at the end of the day, the residual analysis that we're performing ultimately helps us address this question. So is a linear model appropriate for describing the relationship between X and Y? Now guys, remember the illustration that I have here. My X is horsepower and Y is miles per gallon. So ultimately, is a linear model appropriate for describing the relationship between horsepower and miles per gallon? So if car driver calls you up and contracts you out and wants to know, hey, what's the best way to predict miles per gallon using horsepower? Can we use a straight line? Or do we need another more maybe sophisticated model? Well, this helps you determine that, okay? So, guys, the first thing we do is remember a traditional scatter plot. A traditional scatter plot has X on the horizontal axis and it has Y on the vertical axis. And our order pairs consist of a car's horsepower with its miles per gallon. And that's cool. We use those. We look for, you know what, linear tendencies. And hold on, my dog wants out. All right, I'm back. Sorry about that. So we look at the linear tendency between our initial horsepower and miles per gallon. Well, we kind of use that in a way, but the plot that I want to look at next helps us address whether or not that relationship is linear. So what I want to look at next is called a scatter plot of our residuals as remember we put those in L3 over our X variable, which we put in L1. So guys, what we're seeking to find here is we want to create this new scatter plot where on our x-axis we have our x variable, imagine that, but our y values are our residuals. So going back to our original data set, instead of having, for example, our ordered pairs that we're concerned about being horsepower and miles per gallon, which for the Audi would be 162, 231, actually 23.1, right? We're not going to look at that in this case. We want to look at the car's horsepower with its residual. So for example, we can go to our calculator. Let's go to Stat. Let's go to Edit. And for the Audi, we're going to be looking at the ordered pair 162 negative 1.33. For the next car, we would look at a horsepower of 295. Its residual is negative 0.78. So at the end of the day, what we're going to have is we're going to have this residual plot, scatter plot of our residuals, where we have horsepower and we have, again, our residuals. So let's go back to the iPad, and here's the way this is going to work. If we go back again and look at the Audi A4, we have 162 negative 1.33. So I would come here to 162, wherever that may be. Obviously, we're on different scales here. And I would come down approximately to negative 1.33, and I would make a point for the Audi. So this point right here is going to have an X value of 162, a Y value of negative 1.3, and I forget what we said here, 33. Okay. The next car has an X value of 295. And a Y value of negative 0.75. Well, guys, we continue doing this for all the cars, and by hand it would get a little, clustery, and especially if you're making it just by hand and not trying to teach it, it's going to be a little cleaner. But there's a better way, and let me show you this. So ultimately, again, what do we want? We want a scatter plot of our residuals over horsepower. Well, it would make sense that if we want a scatter plot, we're going to go to Stat Plot. That's where we've always gone to do a scatter plot. Let's go there, hit Enter. Come down, select the icon for the scatter plot. Now, what do we want for our X list? Well, we just said we want our horsepower. And what do we want as our Y list? Well, we want our residuals. We put those in L3. Scroll back up. Just as we always do from this plot, we hit Zoom 9. And guys, you get your first residual plot. Now, if I hit Trace right here, you can see that the first point we get is 162 negative 1.33. Well, that's the residual for the Audi. If we go to the other point, we have 295 negative 0.78. That's the residual for the second car, which is the BMW 750. Okay? So ultimately what we have here is we have a scatter plot of our residuals over our original X values. Okay? Now, what's this tell us? Let's, hold on, dog wants back in. Okay, sorry about that. But my dog has a way of, I bet this summer I taught a graduate level stats class and we did it online. And I created about 40 videos and my dog would just be hanging out, you know, just be chilling. And every time I would get started doing a video, the dog would want in, want out. It's like it's almost like it senses that I want to be left alone, so let's not leave him alone. All right, gang, what's going on with this? Ultimately, you know, is a linear model appropriate for describing the relationship between X and Y? Well, ultimately, we can get a lot of information from our scatter plot of our residuals over our original X. If a linear model is appropriate, we're going to see a scatter plot of our residuals over our original X that looks random. Kind of like a shotgun blast. Maybe too violent metaphor, but anyway, there's no discernible patterns. If a linear model is not appropriate, then we're going to see something that looks like this, what we call a U-shaped. So it's kind of strange that for something to be linear, our original scatter plot of X over Y should show a straight line pattern. But this corresponding residual plot will be random. If we get something that's clearly not a straight line, so we get something like that. And you don't have to have a PhD in mathematics or statistics to see that, you know, a straight line would not do a good job of modeling that relationship. It does up here, doesn't it? And that's fine. That's perfectly fine. In fact, it's perfect. But not here. In fact, down here, guys, I would probably want something more of a curved relationship. But nevertheless, if we have something like this, our residual plot is going to create a U. So at the end of the day, that's the kind of things I want you to know. So our scatter plot right here, does that look U-shaped or does that look random? To me, it's a no-brainer. It is random, so we can conclude that a linear model is appropriate for describing the relationship between horsepower and miles per gallon. Now, what if you get a U-shaped? Let's say, let's make this real dramatic. Let's say you wrote a $100,000 grant and you received your money and you run your analysis and you find out that a linear model is not appropriate. So what do? Do you just throw the baby out the bathwater and say, well, I guess I have to give my money back. I just don't have a linear model working for me here. Well, you don't. What you do is you get another model. Now, guys, we don't learn we don't learn these models in this class. But if you go to your calculator under Calc and just scroll down, you can see that there are a lot of other regression models that we could use, we could choose from. So if a linear model is not appropriate, well, maybe a quadratic regression is appropriate. Maybe a cubic regression, maybe a quartic. There's another linear with just the A's and B's switched. Natural log regression, exponential regression, power regression, logistic regression. There's a trigonometric regression. So guys, there's all kinds of regression models other than a linear model. So if you get a U-shape on your residuals, it doesn't mean you just, statistics stops working. It just means that we need to search for a model that's more appropriate. And in class, we're actually going to have an illustration of that. So guys, let's leave with a nice, warm, sunny thought. Oh, wouldn't it be great to be there? I'm going to put up one more video And what I'm going to do in the next video is I'm going to have a new data set. I'm going to just go through an entire example for you in full on the stuff that we've just done. So guys, I'm out of here. Have a good one.